Hello everybody, I'm Jose Flores and I'm going to be your instructor for this class in Population Health Dashboards. Today we are going to start with the first lecture and we are going to be talking about defining data visualization. This is going to be the principal topic that we are going to be dealing first, and today our learning objectives are going to be to understand the basic concepts of data visualization. And then today we are going to create that basic knowledge, those basic definitions that are going to help us to navigate the course. Basically, today we are going to be learning a new vocabulary, a new dialogue. How we're going to be doing that, and we are going to remember a little bit about the concept of DIKW, the Data Information Knowledge Wisdom Cascade, that some of you that are in the program of Population Health Informatics we have discussed before in different classes, and those that are not part of the master program but are taking the course as a service course or as an elective, this is a way to understand a little bit of the point of view that we are teaching in a program and how we anchor some of the concepts. Then we are going to be talking why data visualization. We are going to be presenting the pipeline for that data visualization. We are going to be presenting the importance of specifications when we want to do some data visualization, some guidelines, and some common terms. Then, as always, you have the forum to ask questions, and we are going to have the sessions that are scheduled during the week where we can have more interactive activities and bring your questions, or we can run some exercises, some demos, and we are going to make that material available for you as well. Then, with this on mind, let's start talking about DIKW. And when you read the papers, hey, what are they talking about DIK? DIK basically talks about data, information, knowledge as wisdom. But how we do understand those different elements? Remember that data is any element, or those that don't remember but you are just learning, are those elements that we can observe with our senses or we can measure in the surrounding or in the universe or in the world, basically. Then anything that we can observe and we can measure and we can give a number, we can give a label, we can give some description, we are going to call that data. And we are collecting data permanently and we are processing data all the time, and we have this amount of data that is coming to our senses, and then when it comes into our brain is when we are able to create information, when we provide meaning to that data and we have a better understanding of what represents a number, a color, a magnitude, or something, and we give a meaning is when we create information. And when we use that information and apply well in order to accomplish a task, basically we call that knowledge. And if we use that knowledge in order to make the best decision with the information or the data that is available, then we are coming closer to what we can call wisdom, because make the best decision based on data and not in our instance is close to that relationship. Then when we are talking about data visualization, is in reality how we take those observable and measurable units or elements and make them available to human beings in order that that brain is going to be able to digest that data and have conclusions and obtain information, gain knowledge, and be able to make decisions ultimately in that regards. Then why we need to talk about data visualization? Then basically as the idiom says, an image is worth 1,000 words, no? And when we represent quantitative data or qualitative data in visual form, the way that we think, the way that we relate with the data is changed dramatically, and it has demonstrated by research. And when we have visual representation of data, we don't only make the patterns, the trends, and the exceptions in numbers really visible and understandable. They pop up. The visualization is going to help us with that, but also they can extend the capacity of our memory. And if you have taken any of my classes about human-centered design, we discuss a lot of human factors there, but basically I can tell you that our memory, our working memory, is really limited. We can only process 7 chunks of information plus or minus 2, then between 5 and 9 chunks of information at the same time that we are able to have in our brain trying to make sense. And that is going to be competing with other senses and is going to be competing with other sources. Then when we are able to externalize those processes and externalize our memory, our working memory and our processing capability is really, really enhanced. The other reason why we talk about data visualization, or why we need to do data visualization, is because today's world is basically data driven. No, people don't make decision just because they feel that that's the decision that they need to do. We need data to be able to do that decision. We are not making decisions for just gut feelings. We are not making decisions because I think so, and we need to support our decisions in data, and healthcare is no exception. We are generating a lot of data that is really useful, and sometimes we are overwhelmed. Then we have here an opportunity in order to be able to deliver services. All organizations have more data today than ever that they had at their disposal. We are in the information revolution era, or the data revolution era, and we are flooded by data. We are generating and receiving data all the time, and organizations are generating data in so many levels that we need to organize that data in some way. And more organizations use that data and advanced analytics methods to inform the strategic and the operational decisions. And that's also happening in healthcare. We don't make the public health decisions without being informed, without having reliable data, and be able to take conclusions that are going to induce us in the way that we make decisions. That data visualization is going to help us to transform the abstract concepts that can be in a number or in a table, or sometimes that is not easy to understand, into something that is a physical vision, a physical tangible element that we can consume in more approachable way. Also, when we have data visualization, we can allow the users to specify and interact with those visualizations, and then that interaction is going to activate another activities in the brain and be able to generate that knowledge, or generate new elements that are going to help in the decision making process. And powerful means to present compelling stories of data to humans, because at the end, data visualization help us in this. We are visual oriented. As human beings, we are visual species. We are visual animals. We depend a lot on our vision, and we can do some experiments and to see how, when we remove the visual references, we can really be disoriented easily, and that's happened when we have car sickness or motion sickness, is because our eyes and our rest of the body, they are not connected, and that creates those weird sensations. And why we need to do data visualizations? Because we need to understand those types of visual representation that are going to support the exploration, the examination, and the communication of data in order to create new information, new knowledge, and be able to make decisions. This theory is basically provided by Stephen Few in a book that is called Now You See It, a simple visualization technique for quantitative analysis. But it's a common knowledge now, and those are the main reasons why we need to think in data visualization. It's a fantastic tool to facilitate the interaction with data, and it's a fantastic tool to create that engagement of the audience, is to create more information, to be able to provide knowledge to the public in general. Now, let's move into other concepts. Then we have talked about data. But what is a data set? And basically a data set is that aggregation of multiple variables or observations, and we align that with an individual observation and the dimensions of data points. Okay, things that can measure, things can be counted, things can be described. Anything that we can describe or provide a symbol for that is what we are going to be calling a data. And the collection of those measurable and observable entities is going to be then a data set. Then when we have complex data sets, multidimensional data sets, it's important to have exploratory visual analysis and advanced tool sets in order to help us to interact with that data. And one powerful option in that where we can use visualization is to make those data sets and complex data sets accessible and meaningful to the public. And one way of doing that is doing interactive visualizations that we are going to be introducing a little bit later today. Then when we have that data set and when we have that data, what can we do with that? Okay, and what are kind of the processes that we can conduct or perform? And that's what we call the pipeline. And a pipeline is what it says, no? Is a different sets of pipes that are connected in order to move something from the input to the output. And the first element that we need to think about the pipeline of data visualization is how we are going to be importing the data. How we import the data, how we retrieve that required data from the place where it's stored. And this is something that we need to think about, because sometimes we have open access data, but sometimes we have proprietary data. And then what are going to be the challenges, regulations or agreements that we need to overcome in order to be able to retrieve that data? But sometimes that data is in a format that we cannot use. The format can be in a database, and we need that in a file that is separated by commas, or there could be different representation, even worse. It could be in a DVD, in a CD, or in a diskette, and we don't have a way of reading that. Then really important is to be able to import and retrieve that data from that desired data location or data source. And that's the first step. We need to establish the procedure to be able to access and retrieve that data. The second step is the preparation, because even though if we are able to retrieve, to import the data into our system, sometimes we don't have values that are normalized. And I remember when I was doing a multi-country study and we were measuring glucose, some countries measure the glucose in millimoles and the others measure the glucose in grams per deciliter. And then you need to normalize your values in order to make comparable conclusions and comparable visualizations, because if not, you are going to have really weird results, and maybe you are not going to be able to create a visualizations that are going to be useful and help you to make conclusions or to the public make conclusions. We also need to correct to make corrections if we have erroneous entries, and we need to do something with missing values. Basically, that's something that also is called cleaning the data. And that's a crucial element because sometimes errors in the data entry can just break our pipeline. No, if for example a system is expecting to have numbers and for some reason we are providing characters in that field, it can break a formula, it can break a process, and simply the visualization is not working. And why is not working is because we have errors in our data set, and then we cannot use that properly. And also we need to know what we are going to do with missing values and how we are going to manage them, because do we want to smooth curves or we want to have some dents there. And we are going to be seeing some interesting behavior when we start looking into COVID data in the daily base. We see some behaviors that basically you can say, hey, here is a weekend, because you are going to have some missing values during the weekends that people is not reporting, or the labs are not open, or the clinics are not open. Then we have a reduction on the available data in those days, for example. Then we need to learn some techniques in how we are going to handle those missing values in order to make smooth curves. And then from there we go into manipulation, and that manipulation is talking about how we are going to select the data that is going to be involved in our visualization. If we are going to have some kind of filtering, and what are going to be the type of operations that we want to do with that data that we are going to visualize. When we talk about manipulation, it's not that we are going to alter the data itself. We are just going to make that accessible and be able to make that available for the community. Because, for example, we can have coding things 0 and 1, but what is the meaning of 0? What is the meaning of 1? Then we need to use the data dictionaries in order to provide the representation of those different elements. And also then, once we have defined that manipulation, we need to map the data that we have into different geometric primitives. And we are going to learn some of those geometric primitives today. And there are going to be points, there are going to be lines, there are going to be colors, there are going to be hue values, there are going to be the different ways of being mapped into geometric primitives or marks or lines that we are going to have there. And there are some principles in order to do better visualizations, as those are part of the ones that we're going to be discussing, learning, and applying. And at the end, then, of course, when we decide that mapping and we do the operations, then we are able to render, and it's basically transform those geometric data into the actual visual representation. And that's when we create the representation. Then when we are talking of visualization, it's not just, hey, we have the data and we just run the process and we have, voila, a nice graph. As you see, we have a process that we need to be careful, because any of these elements, or the import, or the preparation, manipulation, mapping, and the rendering, can be broken if we don't if we are not careful enough and we don't pay attention. Then that's an invitation that when we are talking about visualization, creating dashboards, and creating these elements, then we need to think about that the process starts, okay, I have the data, how I'm going to retrieve the data, how I'm going to be able to clean it, what kind of manipulation or transformation I need to do in order to make it usable, or what is the type of question that I want to answer, how I map that into principles, and then how we execute the rendering. And as you are going to learn, there is a lot of human factors involved in the way that we conduct the mapping, and there is another basic knowledge about the statistics, about data manipulation, and something that we need to do in the early stages. How do we create then efficient and effective data visualizations? Then we need to have something that we call visualization specification, and those visualization specifications that we are going to be studying that provide various ways that a user can specify what they want. Then that's basically what's the problem, what is the question, and what is the type of message that we want to transfer or to transmit. And if we want efficient approaches for data visualizations, then those processes need to be efficient. That means that we use the less resources needed and the less space and visual space needed in order to be able to convey the information, and scalable. And it means that if the data grows, then we need to be able to expand with the data and be adaptable in that regards. And the two more important steps of the pipeline that are going to be affected by the efficiency is the manipulation and mapping. Because if you are having a lot of data incoming and you don't have that data manipulation and mapping streamlined, you are going to be running the processes manually, and maybe it's not the most efficient way, or you are not capturing enough errors, or you are not cleaning things quick enough, and you are going to have a backlog. And also for data visualization, we create a data visualization recommendation, or what is going to be that product. And when we understand what data we need to visualize, which story we want to tell, and how to visualize. This doesn't come magically. Even though there are some principles, this is going to be in any case a trial and error exercise. This is a human-centered design exercise, and then we need to have a public that is going to observe the different elements and the different products that we are creating, and we need feedback, and then we maybe need to go back and look into the mapping and see if that story, that specification, and the mapping that we are using to tell the story to comply with the specification is working, and if not, we try another way. Experience is going to shorten our path, but in any case, somebody is specifying a problem, we have some ideas, but sometimes the data is not coming in the way that we can use that in the way that we imagine. Then we need to change our goals and go into that cycle that basically is what is the data, what is the type of mark that we are going to be using, and how we are going to do that mapping, and this is an iterative process. Then let's talk a little bit about this process of creating those specifications. And then the first step is the data. Okay? And the data, then we need to identify those records, those registry, those sources that we need to be visualized. And then we need to understand what are the transformations or the operations like grouping, binding, filtering, sorting, in order to make that data usable. Then we are going to have the data that is going to have those two components, the records, and we are going to have the transformations. And that's going to be part of our specification that we need to create. Then now we need to think about the marks. Okay, what is the type or the visual representation that we are going to be using for that particular type of data, and is going to convey the message that we want to do. Then when do we choose a bar, when do you choose a line, when we use a point? Okay, and the size, what is the width, the height of that visualizations, and that width, that height is going to convey another meaning, because we need to take into account what is the size of those marks. Then is the size by itself conveying some information, or be able to produce some trigger of information in the brain of our audience. And we need to have legends. Hey, how we are going to explain what the type, what a bar, a line, a point, or what the size or what the colors represents. Then we need to think about that, how we are going to name things, how we are going to make the image self-explanatory and be able to understand quickly what is going on. And other properties that we need to consider in the marks or the visual cues is colors or density or hue or other physical properties of the visual aspects that are really important. And we are going to be discussing extensively about marks, about visual cues, and especially color. Color is going to be interesting discussion because we have colorblind people, and sometimes we don't test our visuals for color blindness, and if the color is conveying some information, we can be missing that communication with our subjects. And then at the end we do the mapping, that basically taking those maps, that data and mapping them into the corresponding marks. But you were thinking, what is this? What is Jose saying here? What is Dr. Flores saying here? I'm kind of loose. Then this is a recommended representation by the World Health Organizations, and I invite you to save this slide and come to that when you are having problems. Then basically you ask yourself, what would you like to show? Are you showing a comparison? Are you showing a distribution? Are you showing a composition? Or are you showing relationships? And these are not only the four, and these are not the only operations. Actually, there are 7 that we are going to be studying, but this is a really good starting point. Then you want to compare over time, or you want to compare among items. And then you have more than one variable by item, or you have one variable by item. And then you can start doing these questions, and it's going to help you to orient in what type of mark, and then how is better map your data type into, or not your data type, your function, your story, the activity that you want to do into the best visual representation. Okay, then this is going to be a key element that we are going to be revisiting, and I recommend you to always have that handy. Now, if we are able to have our data, we know what is going to be our functions, and we create the proper mapping, there are other rule of thumbs or recommendations that we can consider. And those 10 key rules for presenting visualized information are: first, we need to identify who is going to be our audience. Why? Because once we understand the audience, we can adapt the content to that particular audience. We can talk the language. We can personalize the content to our audience and be more effective. We need to be sure that the data is clean, because as I said before, we have a lot of noise, or we have dirty data. Our representation is not going to be the most accurate, and it's not going to be maybe easy to understand. We need to select the right chart. We need to provide the right mapping for the process, and we need to put a label that is going to identify and describe what is going on in that particular chart when we are doing that. We need to emphasize the important points in some way, or because we are using different widths, different lines, different aspects that are going to help us to emphasize. We can use external representation or external elements as arrows or things like that to point into specific elements of data, or create interesting dimensions that are going to create visual cues in order to the users be able to look into those important points. choose the best dashboard, and we are going to be talking a lot about how to achieve that, and how we are going to organize things, and how we actually tell the story, and there are different ways of telling stories. Format the chart for accessibility. We already talked about that. Not only being colorblind, but the size of the font depending of our audience. If we have elderly patients and we have really tiny font, maybe they are not going to be able to read it. How we use color, and if the color is conveying meaning, then we need to be careful, because we already know that not necessarily the color is accessible, and we need to be sure that the data can be read in any format. Then and we are going to see multiple representations of the data. And as I told you, since this is a trial and error, we need to be able and be open to accept feedback, because even though we know the audience and we do everything correctly and we are following kind of the recipes, we are dealing with human beings and we have particularities. Then that's something that we need to take into account. Then those are basically when we were talking about the why. Then we can see that the benefits of the data visualizations are going to create efficiency in conveying information, in providing some ways of the people to absorb that information and be able to understand complex phenomena, or at least the phenomenon that we want to describe. It's going to help groups achieve insights about the nature of a problem, and they can discover new understandings about the problem, and they can allow to share the view of a situation and align people when we need to have actions. Then when a clear visualization, you can basically orient the people towards a decision, and sometimes we want to do that, and that's what marketing does. Marketing explore our visual cues, our reward zones, and our reward zones in our brain, in order to activate them and be able to trigger or target us to specific actions. Then if we want to have effective visualization, again, we need to know the audience. We need to provide context and incorporate instructions. It's not sometimes just the screen there, just the image there, but we need to make the user walk through the visual and bring their eyes to different positions. Sometimes we do that with words, sometimes we do with the same visualization. If we can add interactivity, the visualization is going to be much more effective, and that's something that is really easier to convey when we have visual computer-based visualizations, that the ones that are going to be building, that we only have paper-based. And always we need to apply those visual best practices. And what are those visual best practices? Then we need to choose the right chart for the data that we have and the purpose of the visualization. Then I already showed you that graph that I recommend you to have always accessible, that is going to help us to make that type of decisions. We need to emphasize the most important data. Then we highlight that data in some way. And less is usually better. We don't want to overload our audience with visual cues, because when you have a busy environment, then our brain just shuts down. And I was telling you, we only have a limited bandwidth in our brain in order to process things, and our working memory only handles 7 plus or minus 2 chunks of information when we are processing that in our brain. Then we need to be really careful there. It doesn't mean that we cannot have more than 7 elements in the screen, but in the way that people are picking things, yes, less is usually better. Limited the colors and the use of colors, and we need to strive for consistency. And those that has already taken the human-centered design class, we have discussed highly why consistency is important. But basically, is when you want to convey meaning, sometimes if you are not consistent, then you can trigger different behaviors in your brain and different results. And we need to learn how to use the space efficiently. Okay, we have been 35 minutes in this talk. We are going to make a break here before continue.